In this video from ITFreeTraining, I will look at how to configure the IP4 protocol and also a little bit on how to configure the IP6 protocol, since some of the configuration is very similar. However, in the IP6 course, I go into a lot more detail about IP6. Understanding how to configure these protocols and what options are available is a valuable skill for an administrator to successfully configure and set up networks. To configure networking on Windows, first I will open the control panel. Once the control panel is opened, I will next select the option Network and Internet. Once open, I will next select the option Network and Sharing Center. The Network and Sharing Center provides a central area for management and configuration of networking in Windows. It provides a quick way to access wizards to configure networking, for example, setting up a VPN or new connection. Also, it shows a map of the local network. Here you can see what networks the computer is connected to. This includes physical network cards and also connections via devices like VPNs. To configure the networking on one of the network adapters on this computer, I will select the option on the left, Change Adapter Settings. This will show all the network connections that are currently physically installed or configured. For example, a VPN connection may use a special network adapter in order to operate. If this is the case, the physical network adapter will appear and also the VPN connection will appear. To configure the network adapter, I will right-click the adapter and then select the option Properties. The network adapter contains clients, services, and protocols. At the top, notice Client for Microsoft Networks. This allows the computer to access resources on a Microsoft network. For example, access a Microsoft network share. It is also possible to add additional clients, for example, add a client for Novell networks. Below this is Services. The first service is File and Printer Sharing for Microsoft Networks. This, as the name suggests, allows this computer to perform file and printer sharing to be used by other computers on the network. If the administrator wanted to disable file and printer sharing, it would be a simple matter to untick this service. If the service is unticked, this effectively disables all file and printer sharing on that computer. Usually the administrator would disable the file sharing through the control panel, as unticking the service here will also disable administrator shares. The next service is Quality of Service Packet Scheduler. The default setting reserves 20% of the bandwidth for services like Windows Update and license renewal. It is possible to change this percentage using group policy. If you untick this option, no bandwidth will be reserved, meaning that 100% of the bandwidth can be used for software running on the computer. However, if the computer is transferring a lot of data for long periods of time, this may prevent updates and other Windows functions from working. At the bottom are the protocols. The first protocol is Link Layer Topology Discovery Responder, otherwise known as LLTD. This is a technology developed by Microsoft that allows data to be obtained from computers on the network that then can be used to create a map of the network. This service responds back to LLTD requests. This means that other computers on the network can send requests to this computer and it will respond back. For example, using LLTD will allow other computers to identify what operating system is being run. Having the protocol appear here, however, does not mean that it will respond to LLTD requests. If LLTD is disabled, it will not respond to requests. Unticking the protocol will ensure that it will never respond to LLTD requests, even if it is enabled in the operating system. The next protocol that I will look at is the Link Layer Topology Discovery Mapper I/O driver. This protocol controls the sending of LLTD messages. This sends data about this computer using LLTD on the network so that other computers can use LLTD to build a network map. Below this is the protocol Microsoft Network Adapter Multiplexer Protocol. This should be unticked. If NIC teaming is used, this will be ticked and all other items will be unticked. NIC teaming is when multiple network cards are combined together to form the one network adapter. This protocol is used by the NIC team to communicate with each physical network card. The next protocol is Microsoft LLDP Protocol Driver. This is similar to LLTD in that it allows devices to transmit information to each other, which can be used to build a network map. The difference is that this protocol is a vendor-neutral protocol. LLTD is a Microsoft protocol. I will next select the protocol Internet Protocol version 4. This is where the administrator will configure IP4. Once selected, I will next press the Properties button to configure it. By default, the setting Obtain an IP address automatically will be selected. When this setting is selected, Windows will attempt to contact a DHCP server in order to obtain an IP address. Below this, notice the option Obtain DNS Server Address Automatically. When this is selected, Windows will attempt to obtain the IP address of a DNS server or servers from a DHCP server. On most networks, the DHCP server will be running, which allocates IP addresses to clients. On a home network, the network device that is used to connect to the Internet will in most cases be configured as a DHCP server. If the computer is plugged into a network that does not have a DHCP server configured, the administrator may want to configure network settings that will be used in this case. If I select the tab Alternate Configuration, this is where the settings are configured that are used when Windows cannot contact a DHCP server. By default, the option Automatic Private IP Address will be selected. When this is selected, and when Windows cannot obtain an IP address from a DHCP server, a random IP address will be used. This will start with 169.254. The idea is that if multiple computers are connected to the same network that does not have a DHCP server, the computers will be able to communicate with each other. However, this IP address is not routable on other networks or the Internet. If the administrator wants to use their own configuration, the option User Configured can be selected, and then the details configured below this. This is useful to the administrator when they have a computer that connects up to a network that does not have a DHCP server, and they want to use their own configuration when this occurs. However, the computer at other times will connect to networks that do have DHCP servers, so static configuration in this case would not make sense. If I now go back to the General tab, I will now configure an IP address. To do this, I will select the option Use the following IP address. I will now enter in an IP address, subnet mask, and default gateway. When an IP address is configured like this, it is referred to as a static IP address. Below this, the option Using the following DNS server addresses will automatically be selected. For this, I will enter in an IP address for a DNS server. On most networks, there will be 2 DNS servers. In this case, I will only enter in the one, or at least only one for the moment. This is all the basic IP settings that need to be configured in order to have the computer communicate on the network and have the traffic routed on the Internet. In some cases, more configuration may be required. To configure more settings, I will press the Advanced button. At the top, notice the section IP Addresses. In some cases, the computer may need to be assigned multiple IP addresses. To assign a second IP address to this computer, I will press the Add button. This will allow a second IP address and subnet mask to be entered in. Once I press the Add button, a second IP address will be added. When multiple IP addresses are assigned to the same computer like this, it is referred to as multi-homing. An example of when this may be used is with servers. For example, a particular service may be being moved from an old server to a new server. The old server is shut down, but the clients are still attempting to access that service using the old IP address. The solution is to give the new server the IP address of the old server. It can now respond to requests on the old server's IP address and the IP address the new server was originally allocated. When all the clients are using the new server IP address, the old IP address can be removed. This concept also applies to the section below for default gateways. In this case, I will add a second default gateway. Additional gateways work differently than additional IP addresses. Windows will use the one default gateway until it detects that it is not working. When this occurs, it will switch to the next default gateway. Windows will keep using the working gateway until it fails. So if the first default gateway becomes available again, Windows will not switch back to it. I next will select the DNS tab. At the top, the DNS servers can be configured. Currently, there is only one configured. It is possible to configure two on the previous screen. However, on this screen, the administrator is free to configure more than two if they wish. If I press the Add button, I can add a second DNS server, which I will do now. On most networks, 2 DNS servers are enough. On some networks, 3 DNS servers are used. Keep in mind that when resolving names, each DNS server will need to be contacted. Having too many DNS servers can cause delays on unresolvable names, since Windows will wait for each DNS server to be contacted and state that the name could not be resolved. Under the DNS servers are the settings that can be configured for how unqualified names are handled. To understand what an unqualified name is, consider the following example. The unqualified name in this example would be on the left-hand side, App Server 1. An unqualified name cannot be resolved by DNS, so a suffix must be added. To show this better, I will open a command prompt. If I attempt to ping the unqualified domain name, App Server 1, notice that this is resolved to an address. On closer inspection, notice that the suffix ITFreeTraining.local was added to the unqualified name. This was found by the DNS server and the IP address returned. So the unqualified name had a suffix added to become a fully qualified domain name, which the DNS server could resolve. If I now go back to the advanced settings, the settings at the bottom section determine how a suffix will be added to an unqualified domain name. The top option is Append Primary and Connection-Specific DNS Suffixes. The primary suffix is stored in the system properties. If I open the control panel, I can select Network and Internet and then select System. This will show the basic information for the system. To see the primary suffix for the computer, I will next select Change Settings under Computer Name, Domain, and Workgroup Settings. This will show the system properties. Next, I will press the button Change and then press the button More. Notice at the top under Primary DNS Suffix of the computer, the DNS suffix ITFreeTraining.local. This is the primary suffix for the computer. By default, this is configured to the domain DNS suffix. This can be changed, but it is generally a good idea to keep them the same whenever possible. I will now go back to the DNS settings. So you can see where the primary suffix comes from. However, it also mentions a connection suffix. This is configured further down in the DNS suffix for this connection. If you want to enter in a custom suffix for that connection, you are free to do this. So essentially, when an unqualified domain name is attempted to be resolved, the primary suffix and the connection suffix will be tried, assuming a connection suffix has been configured. The tick box below this, Append Parent Suffixes of the primary DNS suffix, does not do anything given this example. So let's look at an example where it would do something. When this tick box is ticked, name devolution is performed on the primary DNS suffix until only 2 labels remain. So, what does this mean? If in the following example this DNS suffix was configured, when an unqualified DNS name is attempted to be resolved, the following will happen. First, the complete DNS suffix is added to the DNS name and tested. The next step is to remove the leftmost label and test again. So in this example, the sales label is removed and the test performed again using the remaining suffix. If the name cannot be resolved, the next step is to remove another label and attempt to resolve the DNS name a third time. The tests stop here because the suffix has been reduced down to 2 labels, the label ITFreeTraining and the label Local. Since only 2 labels remain from the original DNS suffix, If the DNS name cannot be resolved, it will be reported back that the name is unresolvable. This option is very useful when you have a forest with subdomains. Having the option ticked will ensure a computer in the child domain will test the parent domain when attempting to resolve unqualified names. The next option in DNS settings is Append these DNS suffixes in order. When this option is selected, the DNS suffixes listed below will be tested in order. By default, there are none present. If I press the Add button, I will add DNS suffix ITFreeTraining.local. Once added, I will next add the DNS suffix ITFreeTraining.com. This allows the administrator to customize which DNS suffixes will be used. This is particularly useful after domain migrations or changes occur on the network. For example, the DNS name for the company may change, but some servers are still listed under the old name. When this occurs, the old DNS suffixes can be listed with the new DNS suffix while the old services are being migrated. The next option down is DNS suffix for this connection. In this case, I will enter in this value as ITFreeTraining.local. This option does two things. If the option Append Primary and Connection-Specific DNS Suffixes is ticked, this will test the primary suffix and the connection suffix which I just entered in. In this case, I have made it the same as the primary suffix. However, this could be a different value. For example, if this network connection was connected to a different network, the administrator may want to use a different suffix. For example, if the service had two network cards, one connected to ITFreeTraining.local and the other connected to east.ITFreeTraining.local. In this case, the administrator may want to use the east suffix for one of the network connections. The second reason this option becomes important is the tick box, Register this connection's address in DNS. If this option is ticked, Windows will attempt to use dynamic DNS to create a DNS record on the DNS server. By default, the primary suffix will be used. However, if the tick box below this, Use this connection's DNS suffix in DNS registration, is ticked, the DNS suffix for the connection will be used when the DNS record is registered. The next tab I will look at is the Wins tab. Wins is an old Microsoft name resolution system dating back to the Windows NT days. It was the primary name resolution system used by Windows before DNS replaced it. Nowadays, Wins has been deprecated and reduced to a feature rather than a role in Windows Server. I would not be surprised if in future editions of Windows it was removed completely. I won't worry about covering Wins in this video, as it is unlikely that you will be asked any questions on it in the exam. I will now go back to the properties of the network adapter. I will next select Internet Protocol version 6 and open its properties. This course is on IP4, and we do have another course on IP6, but the settings work much the same, so it is worth having a quick look. The first thing to notice on the IP6 tab is the Alternate Configuration tab is missing. This is available on IP4 and allows the administrator to configure an alternate configuration when it cannot be obtained via DHCP. IP6 offers improvements in auto-configuration, so alternative configuration is not required. Just like IP4, the configuration can be dynamically or statically configured. I will now enter in a static IP address and other details like the DNS servers. Notice that the process is the same as IP4. The only difference is IP6 addresses are used rather than IP4. If I now press the Advanced button, you will notice the interface is the same as the IP4 interface. The only difference is the IP6 addresses are used. So essentially, there is no real difference. If I now select the DNS tab, notice that interface is the same as the IP4 interface. Also notice that the settings for the DNS suffix have been used. The DNS suffix settings are shared between the IP4 and IP6 settings. The last thing to notice is that the Wins tab is not present. Wins was designed for IP4 and does not support IP6, so thus is not present. I will now go back to the General settings and will configure it to obtain an IP address and DNS servers automatically. I will also select the IP4 protocol, open the properties, and configure it so it also obtains this configuration automatically. Once done, I will exit out of the adapter settings. There is no DHCP server on this network, so the adapter will need to automatically assign settings to itself. To have a look at what gets assigned, I will right-click on the Start menu and select the option to open a command prompt. To see the configuration assigned to this computer, I will run the command ipconfig. Notice that an IP6 IP address has been automatically assigned. In the IP6 course, I will go into a lot more detail about this type of address. The next line down, notice the IP4 address that has been assigned. This has been assigned using a PIPA. This IP address will allow the computer to communicate with other computers on the same network that have an APIPA address. That covers it for the basic configuration of the Internet Protocol on Windows computers. I hope you found this video useful and hope to see you in other videos from us, in particular our course on IP6. Until the next video, I would like to thank you for watching.